Sample 21 on pipe friction in turbulent flow. Oil of specific gravity 0.85 with an absolute viscosity 0.0056 Pascal second flows at the rate of 80 liters per second in a 150 mm diameter pipe having absolute roughness of 0.9 mm. Find the head loss per kilometer. Determine the maximum shear stress. Find the velocity 25 mm from the center line. And under these conditions, is the pipe behaving as fully rough, transitional, or smooth pipe? So for the head loss, we must compute the velocity first and then the Reynolds number to solve for the friction factor. So velocity 4 times discharge over pi diameter 0.15 square. So 4.527 meters per second. Then the Reynolds number is diameter 0.15, mean velocity 4.527, density 850 kg per cubic meter divided by absolute viscosity 0.0056 Pascal second. So the Reynolds number is 103,070, which is turbulent. The flow is turbulent. So next is the friction factor. So 1 over square root of F equals 2 log of Reynolds number square root of F over 2.51. Let's assume first that the pipe is smooth, although absolute roughness is 0.9 mm. But let's check. So 0.01788 if the pipe is smooth. So thickness of viscous sublayer is 14.14, diameter 150 over Reynolds number 103,070 square root of friction factor. So the thickness of viscous sublayer is less than the absolute roughness, and however it is greater than E over 14. So it means it is E over 14 is less than thickness of viscous sublayer less than E. And we assume it is smooth. So therefore, this friction factor must not be acceptable. So next, we recompute F as in the transitional situation. 1 over square root of F equals negative 2 log of E over 3.7 diameter plus 2.51 over Reynolds number square root of F. That's the formula. Absolute roughness over D over 3.7, the opposite of the formula when this is positive. And for the smooth pipe also, it's the inverted formula from this term here. So solving for F using your high-tech calculator, it is 0.03293. Then recompute thickness of viscous sublayer to verify if it is in this range. 14.14 times 150 or 103,070 square root of 0.03293. So the thickness of the viscous sublayer is 0.1134, and still this is less than E but greater than E over 14. So E over 14 less than thickness of viscous sublayer, which is equal to this in mm, and less than E, which is 0.9. So that's correct, that the pipe is in transitionally rough pipe. So it is the transition from smooth to rough pipe. So we accept this value because it verifies the result. So therefore, we can now compute the head loss per kilometer. HF is FL over diameter velocity head. So head loss is friction factor 0.03293, length 1000 because this is per kilometer over diameter, velocity head 4.527 square over 19.62. So the head loss per kilometer is 229.3 meters. Then determine the maximum shear stress. The maximum shear stress occurs at the walls, and it is gamma, specific weight of liquid head loss, times the diameter over 4 times length, Although there is another formula, F rho V square over 8, but we will use this. Specific weight is specific gravity times specific weight of water in newtons per cubic meter. Head loss to 29.3, diameter 0.15 divided by 4 times length, 4 times 1000. So the maximum or the maximum shear stress or the shear stress at the walls is 71.7 pascals. Then find the velocity 25 mm from the center line. Velocity V sub r for turbulent flow is V sub c minus 5.756 square root of tau max over density times log of RO over R sub O minus R. So that's the formula if you can remember. Where V sub c is mean velocity times quantity 1.326 square root of f, and we have already computed f. So V sub 25 equals V, quantity 1 plus 1.326 square root of f, that's V sub c, minus 5.756 square root of tau max over density, log of RO 75, radius 150 divided by 2, so 75 over 75 minus R. So it's a matter of calculations. So V sub 25 is 5.322 meters per second. Then finally, under these conditions is the pipe behaving as fully rough. It is already explained that since 0.9 over 14 is less than the thickness of viscous sublayer and the thickness of viscous sublayer is less than 0.9, the pipe behaves as transitionally rough pipe or transitionally rough. So that's the answer to this problem.